Good day. For those of you who do not know me, my name is Douglas Harder, and in this topic, I'm going to discuss energy conversions. So, in this topic, I'm going to describe what energy conversions are. I will explain how to perform these conversions, and we will look at some examples. Now, in chemistry and other sciences, it's not that uncommon to see conversions of measurements of such things as the wave number, normally in units of per meter, frequency in units of per second, energy measured in hartrees, molar energy, kilojoules per mole, and temperature. Now, normally such conversions are verboten. After all, you cannot convert, for example, Kelvin into joules. Nevertheless, if you look on the internet and in a relevant textbook, you will find lists of such conversions. Now, these are referred to as energy conversions, and this is not to be confused with simply converting two units of energy between each other. For example, converting kilojoules to British thermal units. Instead, the conversion between the units that I've described above use the fundamental equations that equate energy with mass, with temperature, and with frequency and or wave number. Now, the tables and unit converters usually provide the scalars or conversion factors relevant to such conversions, but they don't give the theory behind these conversions. The theory actually uses some of the very familiar equations. E equals mc squared, where c is the speed of light, and E is equal to h times frequency, where h is Planck's constant. Thus, for example, these essentially state that 1 kilogram has the energy of c squared joules, which is approximately 9 times 10 to the 16 joules, and per second has an energy of Planck's constant joules, which is approximately, again, 6.6 times 10 to the negative 34 joules. Okay, now to convert seconds to meters. From the formula 1 kilogram is equal to c squared joules, we see that 1 kilogram is therefore equal to c squared kilograms meters squared per second squared. Now we can cancel out kilograms on both sides, and consequently we have that 1 is equal to c squared meters squared per second squared. Since everything is positive, we can take the square root of both sides, and simplifying we get that 1 second is equal to c meters, where c is of course the speed of light. Thus, 1 second has the same energy as approximately 3 times 10 to the 8 meters. From these, we can now convert between mass, energy, length, time, and other such units. But the question is, in general, how do you convert, if at all possible, between newtons and watts, or perhaps between pascals and meters per second? In implementing the Maple Units package, this could not be done as a lookup table because, after all, the user may wish to convert between pounds per foot to pound force. Don't know why, but they may. So, to determine the conversion factor between any two units, this package converts all units into a common unit as follows. So, we're going to convert all units to a common reference. We could use joules. After all, these are all energy conversions, but this is a problem because joules are a derived unit. Instead, the Maple Units package chose the base unit of the meter. Alright, so if both units do not convert to the same power of meters, an energy conversion is not possible. If both units are able to convert to the same power k of meters, then we have that the first unit is some constant times meters to the power k. The second unit is that a new constant times meters to the power k. And thus the conversion factor from unit 1 to unit 2 is the ratio C1 over C2. Thus, we have to convert everything into meters. Well, we already have the third one telling us that 1 second is equal to C meters. Let's convert the others. Isolating joules in the second equation, we have 1 joule is equal to 1 over Planck's constant per second. If you combine this with a third to replace the second with C meters, we get that 1 joule is equal to 1 over C times H per meter. Substituting this into the first equation, we now get that 1 kilogram is equal to C squared over CH per meter, which is C over H per meter. Thus, for example, it's not possible to convert between kilograms, which is equivalent to 1 over meters, and seconds, which is equivalent to meters. We can, however, convert between kilograms and per second. 1 kilogram is equal to C over H per meter. 1 second is equal to C meters, therefore 1 per second is equal to 1 over C per meter. Thus, 1 kilogram is equal to the ratio of C over H all over 1 over C, which is equal to C squared over H per second. Additionally, we have this formula. Energy is equal to the Boltzmann constant times temperature. And thus, 1 Kelvin is equal to the Boltzmann constant K joules. And as 1 joule is also equal to 1 over CH per meter, we therefore have that 1 Kelvin is equal to K joules, which is equal to K over CH per meter. Now, as for electric current, under a previous definition of an ampere, using Ampere's force law, we deduce that the following two are equivalent. Thus, an ampere squared is equal to a kilogram meter per second squared. We will now substitute a kilogram for its corresponding units in terms of meters, and we'll replace seconds with C times meters. This gives us this expression here, and we can then simplify to see that an ampere squared is equivalent to 1 over C times H per meter squared. Thus, taking the square root of both sides, as everything is positive, we see that 1 ampere is equivalent to 1 over the square root of CH per meter. By definition, 1 candela is 1 over 683 watts per solid radian. Thus, 1 candela is equal to that formula there. We can replace the watts with joules per second. And since 1 second is equal to C meters and 1 joule is 1 over CH per meter, we can substitute both of those into the previous equation to get that 1 candela is equal to, once we do the math, 1 over 683 C squared H per meter squared per solid radian. Now, 1 mole is a specific number of atoms or molecules. The only conversions I've ever seen convert 1 mole to the corresponding number of atoms or molecules. So 1 mole is by definition Avogadro's number, which is the number that is seen here. That's not really an energy conversion, but it seems to be more of a conversion of convenience that is used while doing other energy conversions. Thus, in summary, we have a table of the following equivalencies, where, for example, a second is equivalent to C meters and a Kelvin is equivalent to Boltzmann's constant over the speed of light over Planck's constant per meter. Now, one website that provides such conversions is seen here. However, this website restricts units to those that are equivalent to energy or joules or per meter. Going back to our example, however, suppose someone actually wanted to convert from pounds per foot to pound force. Well, let's go through the math. 1 pound is exactly equal to this many kilograms. 1 foot is equal to exactly this many meters. Thus, 1 pound per foot is approximately equal to this floating point number. And substituting kilograms and for its units, which is C over H per meter, we get that a pound per foot is proportional to 1.5 times the speed of light over Planck's constant per meter squared. Let's look at pound force. Well, 1 pound force is approximately equal to 4.5 newtons. And a newton is a kilogram meter per second squared. We can substitute the equivalence of 1 kilogram and the equivalence of the second to get that 1 pound force is this expression here, which simplifies to 4.45 per ch per meter squared. Therefore, in converting from pounds per foot to force, we take the ratio of these two numbers. Calculating this, we get this formula here, which is approximately 3 times 10 to the 16 pound forces. I really hope no one ever is in a situation where they actually have to make this determination. But it just shows that it does actually work. Now, the Maple Units package can be used to perform units conversions through the convert command. So, for example, this command converts 1 meter to seconds. Now, by default, the units package will not do this because meters and seconds do not measure the same thing. However, if you give it the option energy, then it will attempt to perform an energy conversion. And in this case, it will give you exactly 1 over the speed of light. If you tried to convert kelvins into joules, you get the number that we saw previously. And if you wanted to convert 1.2 joules per Kelvin per meter squared into Pascal seconds squares in energy, yep, you can do it. Again, I'm not sure anyone will ever do this and need the result, but it can be done. And it does so using the ideas we discussed previously. In Maple, you can also get help about energy conversions by typing at the command prompt, help for units energy conversion. We can also do dimensional analysis. So for example, I can ask to convert joules into its dimensions with respect to energy, and we get that it is indeed equivalent to 1 over length. Joules per Kelvin per meter squared, when converted into its dimensional analysis using energy conversions, is 1 over length squared. Why? Because joules and Kelvin both measure energy, therefore they cancel each other out, so all we're left with actually is 1 over length squared. And just for fun, the unit, if it's ever used, meter, second, kilogram, Kelvin, ampere, mole, has dimensions 1 over length with respect to energy equivalence. Not that anyone would use that, but just pointing it out. Thus, in this topic, I've discussed the concept of an energy conversion, described the fundamental equations that we used to derive these equations. We looked how we can apply these conversions in general, and then we looked at how we can actually use the Maple Units package to perform these operations. Here are some references, acknowledgements, the Colophon, and a disclaimer. Cheers!